Hello everyone, this is Dr. Suleiman Khan and you are watching my YouTube channel The Beauty of Mathematics. In today's lecture, I will solve an example with the bisection method. The example is show that f of x is equal to x cube plus 4x square minus 10 has a root in the interval 1 2 while using the bisection method. So the solution of this example is, first of all, we will check the value of the function on the 1 while putting in place of x 1, so we can get minus 5, and checking the value of the function on 2, which is equal to 14. So the first condition in the bisection method is satisfied, that f of a and f of b, multiplication of f of a and f of b is less than 0. So when this condition is satisfied, it means that the function, this one, has some root in the interval 1 2. And for the first iteration, what we will do, we will find out the middle point of 1 and 2, which is 1.5, and we will proceed the bisection method. So for the first iteration, we have to find out the value of the function on 1.5, which is equal to 2.375. Substituting the value of x, which is 1.5, in this function, we can get this one, and we have got the positive value. So the f of 1 is negative, and f of 1.5 is positive, and f of 2 is also positive. So it means that the root lies in which interval? In this interval, because f of 1 is negative and f of 1.5 is positive, so we can exclude this interval. This one will be not counted. So it means that the required root p belongs to the interval 1 and 1.5. And we will keep continue this for the another iteration. So it means that we will further divide this interval 1 and 1.5, and we will get the middle point of these two, which is 1.25. And in the second iteration, we will check this value in the given function, which we can get minus 1.796. So this value is now less than 0, means on this point we got the value negative, and on 1 the value is also negative, so we will exclude this one, and the root will be lies over here in this interval. So it means that p belongs to the interval 1.25 and 1.5. And for the next iteration we will check the we will find the middle point of 1.25 and 1.5, which is 1.375. So on third iteration we will check 1.375, which is equal to 0.1621, which is again a positive number. So it means that while substituting this 1.375 in the function, we got the positive value, and on 1.5 the value is already positive, so we will exclude this portion, and we will consider this one. We will consider this interval 1.25 and 1.375. So it means that the root belongs to this interval 1.25 and 1.375. So we will keep continue this and we'll find the middle point of these two, which is 1.3125, and on the fourth iteration we will substitute this 1.3125 in the given function, and we will get minus 0.8484, which is again less than 0. So 1.25, the value is negative, and on 1.3125 is also negative, so it means that the roots belongs to this interval. So the required root belongs to 1.3125 and 1.375. So for the next iteration we will divide this interval 1.3, 1.375, and we will divide this, and the middle point of this is 1.3438. So on the fifth iteration we will check this value 1.3438, which is equal to minus 0.3502, which is again less than 0. So it means that the root belongs to the interval. This value is negative, and 1.3 is positive, so the root belongs to this, and this 1.312 is also negative, so we will cancel this one. So the required root belongs to 1.375 and 1.3438, 1.3438 and 1.375, and we will find out the middle point of this interval, which is 1.3594. So on the sixth iteration we will check 1.3594, which is equal to 594 is equal to minus 0.0960, which is again less than 0. It means that the root belongs to the same interval on this portion, because 1.3 75 is positive, 1.3590 and 1.375. So we will further divide this interval and we will get the middle point of this, which is 1.3672. And for the 7 iteration we will check this value 1.3672 and the function f, and we will get 0.0326, which is greater than 0. It means that the root belongs to this is positive, this is also positive, so we will cancel this portion and the root belongs to 1.3594, 1.3672. So for the 8th iteration we will check, we will continue the same process, and after a few more iteration maybe we can get the required results. But as this is numerically very difficult to compute all these iterations by hand, so in the next lecture I would like to present MATLAB code which can easily calculate all these iterations with a very few seconds and while using the MATLAB code. So see you next time. Thank you.